Assalamu alaikum wa rahmatullahi wa barakatuh. I am the researcher أ.د.منى, specialized in abstract algebra. I am interested in module theory. I have several papers in this field. I will present a series of lectures. In each of these lectures, the most important results of each one of my papers are presented. The goal of these lectures is to present my papers with a simplified explanation of the most important results presented in these papers. We begin by the paper Weak Essential Submodules. This paper was published in 2009 in the journal which was called أ.د.منى Science Journal, and in the present we called Baghdad Science Journal. This kind of submodules lies between essential submodule and semi-essential submodules. Semi-essential submodules was introduced by Elizabeth in 2005, and I found kind lies between this type of submodules and the essential submodule. This submodule is different from essential. Here we use the submodule semi-prime instead of any submodule. I specialized type of submodules in the defined of the essential submodule. So a non-zero submodule n of m is called essential if n intersect L is not equal to 0 for every non-zero submodule L of m. In this definition, I choose semi-prime instead of any submodule. So the definition one as follows: let M be a null module, a non-zero W of M is called weak essential if W intersects S not equal to 0 for each non-zero semi-prime submodule S of M. In this example, I gave example about semi-essential but not weak essential. In fact, in the class of irreducible, the class of irreducible submodule make something. So a submodule n is called irreducible if for each two submodules L1 and L2 of M such that L1 intersect L2 equal to n, then either L1 equal to n or L2 equal to n. We can show that if every semi-prime submodule of M is irreducible, then a semi-essential submodule of M is weak essential. So we said that every weak essential is semi-essential. but the converse is not true. If every semi-prime submodule of M is irreducible, then the converse became true. Lemma 1, 3. Let S be an irreducible submodule of M, then S is semi-prime find only if S is prime submodule. This lemma is found in the reference 5. So by using this lemma, I gave the proposition 1, 4. Let M be a non-module such that every semi-prime submodule of M is irreducible. If a submodule W of M is semi-essential, then W is weak essential submodule. Also, there are some remark and example in 1, 5. Verified some properties of this kind of module. In section 2, I gave weak essential homomorphism, which is defined as follows. Let M1 and M2 be 2R modules. Another homomorphism F from M1 to M2 is called weak essential homomorphism if F of M1 is weak essential submodule of M, and there are some propositions and theorems gave about that section, such as this theorem 2, 5. Let M1 and M2 be R module, and let home M1 W be a proper submodule of home M1 M2 for every submodule W2 of M2. If home M1 W2 is weak essential submodule of M1 of home M1 M2, then W2 is weak essential submodule of M2. After that, there is section 3, which is about weak essential submodule in multiplication module. In this section, I study this kind of submodules in the class of multiplication module, and there is some result, such as 3, 1, proposition 3, 1. Let M be finitely generated faithful and multiplication module, and let W be a submodule of M such that W equal IM for some ideal I of R. If W is weak essential submodule of M, then I is weak essential ideal of R. So this proposition talk about translate the transitive the property weak essential between the submodule W and the ideal I. Also, there are some other result about this about weak essential in multiplication in the class of multiplication module, such as theorem 3, 6. Let M be finitely generated faithful multiplication, and W is submodule of M such that W is equal IM for some ideal I of M. If each non-zero proper semi-prime submodule of M is irreducible, then the following statements are equivalent. 1. W is weak essential submodule. 2. I is weak essential ideal of R. 3. The residual WM is weak essential ideal of R for each M belong to M, and I proved this theorem. After that, I gave section 4 about weak uniform module as knowledge of uniform modules and semi-uniform modules, which introduced by Ali Sabe and Nada Dabba. uh, definition: a non-zero module M is called weak uniform if for each non-zero submodule of M is weak essential, and a ring R is called uniform it if it is uniform module as R module. Well, this some example and remark about this concept, and this is theorem 4.3. Let M be finitely generated faithful and multiplication module, then M is weak uniform if and only if R is weak uniform. This is the hereditary property between M and R, the property weak uniform between M and R, and this is proof of this theorem. Also theorem 4, let M be a module and let M be essential submodule of M such that N does not contain in any semi-prime submodule of M. If N is weak if M is weak uniform submodule, then M is weak uniform submodule. This is theorem is about the relation between submodule and module. When submodule is weak essential, how the module is weak essential. This theorem deals with that fact, and the proof is for this theorem, and after that the corollary 4.5, let M be an R module such that M does not contain in any semi-prime submodule if E lil M of E lil M. If M is weak uniform module, then E lil M is weak uniform module, where E lil M is the injective hull of M. The corollary about theorem 4.4. Finally, this is the reference and abstract in Arabic as well as abstract in English. And thank you very much for your listening.